Alright, second review problem is finding the sample correlation. We've been having difficulty with this since we started doing it. This time, instead of solving for the variance of x and y and the covariance all by hand, we're going to use Excel functions, and then we're just going to plug the answers into the formula for sample correlation and get the answer. So, use an Excel function to solve for the variance of x. Variance, include that guy. There we go. Variance of x, standard deviation. Always the variance to the 1/2 power or the square root of x. Same thing for y. We can use the var function, whatever you want to call it, to the 1/2 power. Same thing, doesn't matter. Use an Excel function to solve for the covariance of x. Don't remember what function solves for the covariance of x? Just start typing in covariance. Oh, returns covariance. Looks right to me. Array 1 would be the x. Or let's say you don't remember what array 1 should be. Just hit this function button. Two data sets. This array 1 is the first data set. So covariance x, the second one is y. Boom. Done. Now solve for sample correlation. Sample correlation is on the top of this function. Covariance. This is the symbol for covariance. This is the symbol for sample standard deviation of x. This is the notation for sample standard deviation of y. Deviation of x times y. And of course, we are dividing the two. So, plug it in. Let's not overthink this problem. And make sure we put in the brackets, right, the parentheses right here, because we don't want to get order of operations mixed up. There we go. Pretty straightforward. So, fill out the tables below for a discrete uniform probability distribution with 6 possible outcomes. The sample space is 1, 2, 3, 4, 5, 6. What is n? Total number of possible outcomes? That would be 6. Something that can be tricky is if, let's say, instead of this sample space, I give you, and this is just for display purposes, I give you this sample space. There's also a 0 in it. Then there, don't just look at this 6 and say, oh, there's 6 possibilities. No, there's 0 too, so there'd be 7. So, easy thing to mix up. Anyways, in this case, it's more straightforward. Express the probability distribution in the table below. So, f of x represents the probability distribution, or the PDF. So, here, this guy is f of 1, which is equal to the probability that x, which, is the outcome, equals 1. So the probability that x equals 1, uniform distribution. First thing you know when it's uniform distributions, everything has the same probability. So the probability of any given thing is just 1 divided by the number of total possible outcomes. I'm going to put my dollar signs in there to lock it in, and let's copy this down. Comment locks goes with it. Just highlight all these and delete the comments. There we go. So this guy represents, this cell right here represents f of 3, the probability of the outcome being 3, 1/6. Here, on the other hand, is the probability that x will be less than or equal than x, so for this first guy, it's a probability that the outcome will be 1 or anything less than 1. It's going to equal that. Just the probability that it'll be 1. Now this is big F of 2, probability outcome will be anything equal to 2 or less. So that equals the probability that, in this case, it equals the probability that it is 2 plus the probability that it is 1. And I can also write it like this: probability that x will be less than equal to 2. So that's what we're looking at for that cell. And that is going to be equal to probability that it is 2 plus the probability that it is anything less than 2. In this case, just 1. And in this case, it's going to be equal to, probability that's 3 plus probability that's 2 plus probability that's 1. Let's put it in a function to make this a little easier on us. Equals the sum of all these guys. Now this is the top. This is the top one. As we drag this function down, we want to keep this the top one, K86 was right here, locked into place. Dollar signs around that, but we want this to go down with us. So beautiful, and we can just copy this down. And we can start out with that function in here too. So equals sum this cell, colon, then you have that cell again. And you know that the first number represents the top cell, so lock that in place, and then there you go, that'll slide down with it. And I'm gonna just, to demonstrate that this works, paste the formulas, same thing, there we go. Now always, this is your cumulative distribution function, your CDF, big F. Always note that your largest value is always going to be equal to 1. So we don't have any outcome that's greater than 6, so the CDF of 6 is always going to be equal to 1, the total probability. And your lowest possible outcome will always be equal to the probability distribution of that same thing. So keep that in mind if you ever get something greater than 1. Obviously not, right? Now we want to find expected value. Expected value, to find expected value, is just you just sum up the value associated to a given outcome plus, the value associated with a given outcome multiplied by the probability of that outcome happening. And then you sum all those different possibilities. In this case, the value of outcome, it being 1, is 1. So there's the value multiplied by the probability that this one's going to happen right there. And, right here we can do the same thing. The value associated with an outcome of 3 is 3 multiplied by the probability that's going to happen. This is the probability f of 3, which represents in this cell. It's the probability that you're going to have an outcome equal to 3. There we go. And we can copy this, paste it down. And now the expected value is going to equal the sum of all of those instances. We know that from the summation thing. We take the sum of all the instances of whatever's after the summation. That would be these guys. There we go. And that's what expected value equals. So don't need another line here. I just have it in there to kind of demonstrate you want to solve for this, but then this is, really what it's equal to. And you can see I got some equations in there for you since we solved for the expected value of x, or mu right here. we're going to plug that into the equation to solve for the variance. Here's the equation that we're given, the summation. So of every instance of x minus mu, or the x minus the sample mean, squared, multiplied by the probability of that happening. So the first step is to try to get, solve for whatever's after the summation for each case. And then the summation says sums them all together. So x, just follow the equation, put in some parentheses. X minus mu, lock this in place, squared, and then we can take this whole thing and multiply it by the probability of it happening, which we solved for above. And that's going to be our answer, And so you could do that for each instance. Bring this down, sum them up. There's our variance of x. Now whenever I have a table like this, it's to help you get to this instance. If you can't, sometimes you can mess up. It's easy to mess up order operations, do something wrong. So it can be easy. It can be better to break this up. So instead of just plugging and chugging like that, I don't have to give you this table. I can just tell you to solve for the variance of x, and you should list all these x's and get this term for each x, and then sum them all together. But the table can help you provide the steps for you to do that. So that's why I provide the table to you, and it makes it easier for you to understand what you got wrong if you miss it. So let's use the table now. X minus mu, which mu is the sample mean, and then this guy is x minus mu squared. So just take that and square it, and then we can bring those down. And now let's find this the alternative way. X minus mu squared. Whoops, sorry. This is x minus mu squared. Sheesh. Multiplied by the probability. Bring that down. Oh, same answer. So however you want to do it. There's the variance of x. Alright, second last problem, I think. And this is an expected value problem again. An analyst predicted the following returns on the stocks A and stock B and for 3 different states in the economy. And we just want to know the expected return of each stock. So this represents a 15% return for stock A. And that's going to happen if the economic state's a boom. Now the probability of an economic state being a boom is 0.4. And the same is true for the rest of these values. So what is the expected return for stock A? Expected value, expected return is going to equal the sum of the value associated with each case multiplied by the probability of that case happening. In this case, there are 3 different cases, 3 different economic states that can happen. Let's put these like this. And for A, there are 3 different values that we can, of returns that we can have. That's these guys right here. The shortcut key to pay special is Control-Alt-V. Very useful. And then the probability of each of those cases, I put P of A right here. Maybe that's not the best notation, but it gets the point across. Is right here. And so the value, which I call A, multiplied by the probability of that value bring it down. We want to sum it. I'll put that there to show that we're summing. There we go. That's our expected return for the A portfolio. Straightforward. And let's move on to B. Now, you know, this is exactly like chapter 1 when we were finding the average of, you know, different instances. Let's say the return, for example. But instead of finding the average, we were finding the weighted average. And then when, you know, we'd be finding the average return, so it'd be right here. But instead of finding just the average, find the weighted average. And then I always said I preferred to put the weighting average, make the total weighting average out of 1, because that mimics a probability distribution. And that's essentially what you're doing when you're finding the weighted average of anything. It's really a probability distribution. So you can reference chapter 1 if you're having a little bit of difficulty of what, you know, those two things and you want to see the bigger picture. Anyways, expected return of stock B. In this case, I'm just going to save everyone a little bit of time. B times probability of B, we put in the same location. Probability of something happen multiplied by the value of that happening. We have our 3 different states. For clarity, we will put these in here just so that you can see. And then sum. Quicker for me to just copy and paste formatting than to click this cell, take my hand off the keyboard, and put in that thing. But, you know, not something you have to worry about unless you're planning on mastering Excel. There's our expected return of B. Last question, which is a little trickier. What is the expected return of a portfolio of 60% in stock A and 40% in stock B? So what we're looking for is expected return of a portfolio. And what we can do in this case is start out with what we want. You know, just write out what we want. Expected return of the portfolio. Now, change that to what the portfolio is. You know, that's equal to the expected return of 60%, the return of A, plus 40%, the return of B. That is this, highlighted up here, is the portfolio. So, then we have some rules. And you're probably like, ugh, where are you getting these rules from? But that's the challenge in an introductory probability class. It's more important for, or according to, you know, Xavier and just books in general, it's more important for me to just touch on a whole bunch of different important probability concepts instead of for us to really master any of them, or master, you know, what I consider the building blocks. So sometimes we have to go back and put in additional rules and stuff. And that's why when you get 70% or 80% on the quizzes, that can be a good result, because, you know, this is an introduction to high level stuff. Anyways, sorry to waste your time. So the best thing we can do is take this starting cell and break it up. So we can just put maybe and you know, these are the rules right here, and it just says anytime you have a plus sign and expected value, you can instantly just cut that into 2 different expected values. So I see the plus sign here, and now I can cut it into two expected values. Expected value, whatever is before the plus sign, 6 times A, plus the expected value, whatever is after the plus sign. It's the same thing. And then this rule right here says if you have a constant in front of a variable, which our variables are A and B, as they vary, then if we're finding the expected value of a constant times a variable, it's just going to be, you can take that, it's just going to be the expected value of the variable multiplied by that constant. So we can do that in this case. And I'll do it like this, that way we can see each part. First, let's focus on the expected value of 0.6 times A. That equals 0.6, I can bring the constant out, times the expected value of A. And this is going to be equal to, now focusing on this part, 0.4 times the expected value of B. So now we got something we can work with. Let's copy this formula down, get rid of all the middle mumbo jumbo. Sweet. And now we can solve. Equals 0.6 times the expected value of A, we know that, plus 0.4 times expected value of B. Great. Alright, last problem. Binomial theorem. You decide to check out the casino in Cincinnati, you run into your professor there, your professor says he loves this game where you just roll a dice, if it's a 6, he wins. And he says that he plays this game exactly 15 times every time he goes to the casino. Last night when he went to the casino he won 5 times. What's the probability of this event occurring? In this problem, I obviously give it to you that it's a binomial theorem. I don't have to do that. You should be able to recognize that 1, there are 15 different events that are being repeated. That the fact that you have a number of events being repeated flags to you that it could be binomial. And then 2, each event that's being repeated, in this case rolling the dice, has the same probability of having a success. And then there's either success or failure. That combination lets you know if it's a binomial. Now anytime I tell you it's a given distribution, whether it's uniform, binomial, Poisson, as soon as I tell you that, then you know information about that distribution. And in general, what is going to be known about that distribution will be its probability distribution function, which is right here, it'll be given to you, the expected value of that, which instead of like a hard calculation, for some distributions are going to be simple, and the variance. Okay, so in terms of binomial distribution, here are the equations for what those things are. But for a Poisson distribution or uniform distribution, these are going to be different. And for a normal problem, instead of me telling you that it's binomial theorem, I can give you this situation. And then you'd have to figure out, what's the probability that he's going to do this, that if he does this 15 times, he's going to win exactly 5 times. 1, you'd have to figure out that it's a binomial. 2, I won't just give you binomial equations. That'll be too easy. So I'd also give you, these equations for a Poisson distribution or a uniform distribution, and then you'd have to figure it out. You'd be like, oh yes, this is a binomial. These are the equations associated with the binomial. I want to use these equations. Anyways, jumping into this problem. Now what I like about how we're starting to solve this type of problem is in 3 different steps or 3 different sections. A lot of times in spreadsheet manipulation, it can be beneficial to put your stuff into sections like this. Step 1 is always an input section. So that's what is distinct about it's kind of like your variables. It's what can change to solve for something. You can see in this problem there are 3 different things that you need to know in order to solve that, and that's n, p, and x. So make an input section. 2, make a calculation section where you do the calculations to 3 get your answer. And for me, I split up, I set up the calculation section in such a way that I'm looking for, the probability that the professors would, if he does this experiment 15 times, there's going to be success exactly 5 times. That's represented by f of 5 in a binomial. Alright, so this is what we're looking for, specifically f of 5 in this case. In this case. And what can be helpful to do is get this set up in such a way that you can put any inputs in here, and then your answers will just change because you have the formulas in Excel. And basically what you'd be doing is you're creating a binomial calculator. And once you have a binomial calculator, all of a sudden now you've created a tool that you can go back to and that you can use frequently. And maybe it's not going to be that helpful for my exams, but doing something like this, being able to set something up like this, will be helpful in your future job. So or internships, co-ops, or whatever. So let's start out with these inputs. N is 15. That represents the number of times that the event is recurring. He's playing the game 15 times. And P represents the probability for any one given situation that'll be a success. In this case, he's rolling a dice. He wins if it's a 6. So the probability of rolling a 6 is 1 over 6. X is the number of times we're looking for exactly for him to succeed, which in this case is 5. Calculations. So, and I probably should have, I'm setting it up for you to see so that you can do this step, but you have to be able to look at this formula and say, oh, first if I solve for NCX right here, then if I solve for p to the x, then I solve for 1 minus p quantity to the n minus x power, then I can just multiply those things together and get the answer. So NCX, combine, number is 15, number chosen is 5. Total number of combinations, probability of x, p to the x, sorry, p to the x. 1 minus p, remember our parentheses, 1 minus p, oops, forgot my equal sign. 1 minus p to the, make sure you have parentheses in here, n minus x. And then we can solve for what f of x is, which is just, each of these terms multiplied together. Boom. There's our answer. And what's beautiful about this is now if I give you the same problem and say, oh, he does this every 16 times, all you have to do is change that to a 16. Now you have the right answer. Or if I say, oh, he instead of flipping a dice, he's rolling a coin, then all you have to do is change that to the probability of success of flipping a coin, which is 50%. And then every time, I like to, when I have an input section, throw these in yellow. Remind me what my inputs are. Now every time that I have a problem like this, all I have to do is put an MP and X and I get the right answer. And so, let's change this back to the state of the problem. 15 times. P is 1 over 6. And X is 5. Now, and this represents, in this case, F of 5.